class, JS3 students. Our subject today is physics. Our topic is turning effect of a force. Now, what is the turning effect of a force? We are defining the turning effect of a force is the product of force times perpendicular distance. Force times distance. That's the definition of moment. It is the product of force and its corresponding distance to the pivot. Now, moments have both anti-clockwise and clockwise moment. When we talk of clockwise moment, we mean the direction of the hand of a clock. When we talk of the anti-clockwise moment, meaning that the opposite direction of a clock. Now, looking at our diagram here, this is for clockwise moment, and this is anti-clockwise moment. Anti-clockwise moment. For us to calculate the clockwise moment of A, we need to have our force here is 4 Newton times our distance 3 meters. Our answer will be equal to 12 Newton. This is for clockwise moment. And for anti-clockwise moment, we have our force to be equal to 2 Newton and our distance is equal to 3 meters. So our moment will be equal to 6 Newton meter. Now remember, the SI unit for moment is Newton meter because force is measured in Newton and distance is measured in meters. Now, we need to go to the principle of moment. Principle of moment. Principle of moment. The principle of moment states that anti-clockwise moment must be equal to the clockwise moment. The anti-clockwise moment must be equal to the clockwise moment. So if we have an object like this, here this is the pivot, here this is the clockwise, and this is the anti-clockwise. So this is our center, which is O. So moment from here to here must be equal to moment from here to here. If this is A and this is B, here should be 2 Newton and here should be a distance of 3 meters. Here should be 12 Newton and here distance of 2 meters. So the anti-clockwise moment must be equal to the clockwise moment. That is the principle of moment. Now, and if the anti-clockwise moment is equal to the clockwise moment, it means that the object is said to be in equilibrium, where the resultant force acting on the object is 0. What is an equilibrium position? Equilibrium position is a position in which the resultant force acting on an object is 0. Now, what are the conditions necessary for an object to be in equilibrium? The first condition is that the anti-clockwise moment of an object must be equal to the clockwise moment, and also the sum of all forces acting in one direction of an object should be equal to the sum of all the forces acting in the opposite direction. Now we have equilibrium states. When we talk of equilibrium states, we have 3 states of equilibrium state. We have the neutral state, we have the stable state, and we have the unstable state. What is the stable state of equilibrium? An object is said to be in a stable state of equilibrium if it returns to its original position after a slight push. For instance, you have a cone. You have a cone. You see that if you push this cone, a slight push here will make the cone to return back to its original position, meaning that the cone is an example of an object that will return to its original position if it is slightly pushed. Now, unstable equilibrium. An object is said to be unstable equilibrium if it cannot return to its original position after a slight push. Now, looking at our cone, we now reverse it. We discover that at this point, our cone cannot return to its original position after a slight push because here the pointed part here is low. The third state is the neutral state. An object is said to be in a neutral equilibrium if it gains or acquires a new equilibrium after touch. For example, we have a football. As a summary, we started with the turning effect of a force, and I said the turning effect of a force is known as moment, and moment is defined as the product of force and its perpendicular distance. I equally said that the SI unit for moment is Newton meter. And for you to be able to calculate moment around a pivot, you must consider the anti-clockwise moment and the clockwise moment. In the same way, for an object to be in equilibrium position, the anti-clockwise moment must be equal to the clockwise moment, and the resultant force acting on that object is 0. That is why the principle of moment states that for an object to be in equilibrium, the clockwise moment must be equal to the anti-clockwise moment. I will send you a note in the form of PDF, your various numbers, and those who are not connected, they'll get their notes in school. Thank you. See you tomorrow.